Today we'll look at solving the following equations. Sine of 2x minus cosine x is equal to 0 over the interval 0 to 2 pi on the unit circle. So to get started, we observe that 2x is considered a double angle. Using the double angle formula, we can replace sine of 2x to 2 sine x times cosine x. Now we will bring down the minus cosine x, set it equal to 0. So once again, what we just did is we replaced sine 2x using the double angle formula and replacing that with 2 sine x cosine x. At this point, we can see that there are two terms in this equation and each term contains cosine x. We'll factor that out as our GCF, which will leave us with 2 sine x minus 1 is equal to 0. Here we can apply the zero product property and let each factor equal to 0. So we get cosine x is equal to 0 or 2 sine x minus 1 is equal to 0. Solving this one for an isolated sine x, we will get sine x is equal to positive 1/2. So we've isolated cosine x and sine x. At this point, we are ready to solve for x, which are the angle measures between 0 to 2 pi on a unit circle. If you look back on the unit circle, cosine values are the x values, and we want our x values to equal to 0. We are on the unit circle with the x values equal to 0. It will be right here at pi over 2 and right here at negative pi over 2 or positive 3 pi over 2. So for cosine x, our x values are pi over 2 and 3 pi over 2. Now, for sine x equals 1/2, recall that first of all, sine is positive in quadrants 1 and 2 using the quick mnemonic all students take calculus. All the functions are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine is positive in quadrant 4. Since sine x is equal to positive 1/2, we are looking for angles in quadrants 1 and 2. Again, recall, we are looking for the reference angle, which will be our quadrant 1 angle, whose sine value is 1/2. The way I look at it is I try to write the coordinate, and I know the sine value is my y value, which is 1/2. The 1/2 always goes with the next value of radical 3 over 2 for my unit circle. And radical 3 over 2, 3 times 2 makes 6, so that's how I remember that my reference angle is pi over 6. So going back to here, our quadrant 1 angle, which is also your reference angle, is pi over 6. And your quadrant 2 angle, the numerator is always 1 less than the denominator for unit circle values. Therefore, we get 5 pi over 6. So that is our answer. There are 4 x values for this particular equation: pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. I hope this was helpful.